Section 7.6, solving radical equations. That means equations with radical in them. And we should always check our final answers because sometimes when you solve these kind of equations, the answer might be not the correct answer. So it will be like what is called as extraneous answer. So you always have to check your answers when you're doing these kind of problems. So how do we solve equations with radicals in it? Well, it depends on the index of the radical. Remember, radicals are, they undo exponents, and exponents undo what? Radicals. In order to get rid of the radicals, we have to what? Raise both sides to some power. The question is, which power should I raise this particular problem? Let's say the problem is solve and check. Square root of x is equal to 5. Remember, sometimes there is no index, so by default that means it's 2, which means you're dealing with the square root. So in this case, because the index is 2, so I'm supposed to raise both sides to the power of 2. So what happens is I get x, because remember when you raise a radical to the same power as the index, the radical sign disappears. So in this case, the final answer is 25. And when you check, you get the square root of 25 is equal to 5. It checks. So remember, this is kind of the same as saying square root of x squared. But remember, when the power of the radicand matches the index, the answer is x. And we're assuming what? X is a positive real number, correct? Solve and check. Cube root of x equals -3. So now I'm going to raise both sides to the power of 3 because I have what? Cube root. Remember, we always raise both sides to the same power as the index of the radical, correct? So in this case, you get x because the 3 wipes out the radical. And -2 to the power of 3 is -8. And the way you check it, you go, is cube root of -8 -2? Yes, it is. It checks. Square root of 7x minus 2 equals -2. First thing first, you got to get rid of the 9. You got to isolate the radical sign on one time before what? You square both sides. The next step is to square both sides. And you get square root of 7x equals 7 squared, which is 7x equals 49. Divide both sides by what? 7. So the answer is 7. Check and see if what? Square root of 7 times 7, which is what? 49, minus 9 is equal to -2. Square root of 49 is 7. 7 minus 9 is equal to -2. Checks. Same thing here. You subtract 4 from both sides. You get the square root of x plus 3 is equal to 1. Raise both sides to the power of 2 because what? The index is what? Is 2. So on the left side, you get x plus 3 because the 2 wipes out the radical sign. Here you get 1. X is equal to -2. Check and see. Remember, these problems come with checking. Check and see if you get the right answer. Is the square root of -2 plus 3 plus 4 equals 5? Well, this is the square root of 1. This is like 1 plus 4 is equal to 5. It checks. Do you see it? So don't forget to check. Suppose now we have fourth root of 3x minus 2 equals 2. So you know what we're going to do. We're going to raise both sides to the power of 4. Why? Because the index was 4. So in this case, that will be 3x minus 2, the fourth root. Here is 2. Remember that 4 wipes out the radical. You get 3x minus 2. Here you get 16. Add 2 to both sides of the equation. You get what? 18. Divide both sides by 3. And lo and behold, you get 6. And make sure you check and make sure it correct. So 3 times 6 is 18. 18 minus 2 is 16. Fourth root of 16 is 2. It checks. What about this guy? Well, you move this guy over first. That means subtract 2 from both sides. Now raise both sides to the power of 2 because the index is 2. Is that right? And that would give you, this guy wipes out the radical. So you get x equals +4. But before you box your answer, check and see if it's okay. What was the problem? square root of x plus 2, is it equal to what? 0. And what did I come up with? 4. Square root of 4 plus 2 is equal to 0. Square root of 4 is 2. 2 plus 2 doesn't add up to 0. So unfortunately, this is not our solution. It's like extraneous solution, meaning a solution which you created, but it's not the solution of what? The equation. So in this case, we say no solution because that was the only answer I got and it didn't work. So no solution. Sometimes no solution is shown by that notation. What about this guy? Well, the index is 2, so you raise both sides to the power of 2, correct? And you kind of go, okay, that 2 wipes out the radical, so you get x squared plus 3x plus 2, 12. Here you get x squared. If you subtract x squared from both sides, you will end up with 3x plus 12 is equal to 0. So that would be like 3x is equal to negative 12. Move that guy over. Divide by 3. X is equal to negative 4. We'll make sure it checks. Well, let's do some checking here quickly. What is it? This is like negative 4 squared plus 3 times 4 plus 12. Is that the same as negative 4? Okay, so that would be like what? 16 plus 12 plus 12. Is that equal to negative 4? I know it's not going to be equal because this is a positive number. As a matter of fact, that's what? 24, which is like what? Square root of 40, is it? And that's like 12 plus 12, correct? But that's not going to be the same as negative 4. How do you get, square root of positive number equal to negative? Once again, this is not our solution. So therefore, we have no solution. So that's why it's very crucial for us to what? To check our answers. This guy, you have to raise both sides to the power of 2 because what? The index is 2, correct? Like so. Here on this side, the radical gets to be wiped out. But on the right side, I have to what? Expand this and multiply it by itself twice. When you do, you get x squared minus 6x plus 9. Okay, that looks like a quadratic equation. Remember, we saw this in chapter 5. So what you have to do is what? Subtract 3x, add 9 to both sides of the equation. So you get 0 equals x squared minus 9x plus 18. Factor this out, so you get x, about 6 and 3 minus. So x minus 6 equals 0, x minus 3 equals 0, so x is either 6 or 3. But you can't box your answers before you check them. So what you have to do is you have to check these guys one at a time. Let's check 6. Where do you check it? In the original problem. So what is this? Is 3 times 6 minus 9 the same as 6 minus 3? I don't know. That's like 18 minus 9, which is square root of 9, which is 3. And on this side, you got 3. So this guy is okay answer. How about the other guy? How about the other answer? What was the other one? X equals 3. Go back and replace what? X is with 3 on both sides of the equation here. And that would give you 3 times 3 minus 9. Is that the same as what? 3 minus 3? Right here. So I'm replacing x's with what? 3. That would be a square root of 9 minus 1. That's 3 minus 3. That's 0 equals 0. It checks. Therefore, the solutions are either 6 or, what was the other guy? 3. So they both check. Do you all see? Finally, we have what? These kind of equations where you have two radicals and a number. So these guys take a while. So the first thing you do is isolate one of the radicals on one side, put the radical and the number on the other side, just like the way this problem is. Raise both sides to the power of 2. So the left side is easy. Why? Because the 2 wipes out the radical. But the right side is not quite easy because that's 6 minus the square root of minus 5 times itself twice. So the radical sign does not wipe out the radical here because you got a subtraction. So you got to multiply these guys out. When you do and you FOIL this, you get what? 36, what? Minus 6 square root of x minus 5 minus 6 square root of x minus 5. And then negative times negative is positive. Then you get the square root of x plus 5 times the square root of x minus 5. You get the x minus 5. Keep in mind, when you multiply x minus 5 by the square root of x minus 5, you get a square root of x minus 5 squared, but the 2 wipes out the radical, so you get x minus 5. Okay, combining the like terms, we have, what do we have? We got 36, these guys combined, we get negative 12 with these guys. Then you got x, then you got negative 5, here you got x, then you got 7. So the next step is to keep the radical, including its coefficient on one side, move everything else to the other side. What does that mean? Subtract 36, subtract x, add 5. So subtract 36, subtract x, add 5 to both sides. So that way you have isolated the radical term on the right side with the coefficient attached to it. But on the left side, let's see, the x's cancel. And this guy gives you what, 12. So that would give you minus, what is it, 24, is it? So now what we do is what? This is an optional step. Okay, so what you do, you kind of divide both sides by negative 12 first. So you get what? Positive 2 equals the square root of x minus 5. So these are a little bit harder problems, correct? Why? Because it takes what? To square both sides of the problem twice, not just once. Once again, I have to raise both sides to the power of 2. I got to keep doing this till I get rid of the radicals, correct? And finally, I get 4 is equal to x minus 5. The 2 wipes out the radical. So it looks like x is equal to 9. But remember, before you check the answer, box the answer, make sure it checks. What do we have? 9 plus 7, is that 6 minus the square root of, say, 9 minus 5? 9 plus 7 gives you a square root of 16. That's 6 minus square root of 4. Square root of 16 is 4. Square root of 2 is 4 is 2. That's 4 is equal to 4. Checks. So therefore, this is our final answer. Right? Sometimes, based on section 7.2, where we could write the radicals in exponent form, sometimes you have this kind of rational exponent. You know that's a radical, right? Move the 3 over by adding 3 to both sides. And lo and behold, you get 4x plus 5 to the power of 1/2 equals 3. But you and I, we both know from section 7.1, when you can convert the exponents back to radicals and vice versa, this is exactly square root of 4x plus 5 to the power of 1. Notice 2 is the index, 1 is the power of the radicand, so this is indeed a radical problem, an equation with radical in it. Okay, raise both sides to the power of 2. Is that right? So the 2 wipes out the radical on the left, so you get 4x plus 5 equals 9. So 4x is equal to 4, subtract 5, and x is equal to 1. But check and see, make sure it's okay. It would be nice if you check it right here in the radical form. So what do we have? We have square root of 4 times 1 plus 5. Is that the same as 3? Yes, that's the square root of 9, which is 3, so it checks. Finally, you got these kind of problems. Once again, the powers are rational, fractions. That means these are radicals. What is it? Believe it or not, this guy is the same as cube root of x plus 4 to the 1. And this guy is cube root of 3x plus 10 to the power of 1. So notice the denominators are always the index. The numerators are always power of the radicand. Because they both have indices 3, so what I would do, raise both sides to the power of 3, to wipe out the radicals. And when I do, these guys gets to be cancelled. So there goes the cube root, gets to be cancelled. So all I get is x plus 4 is equal to what? 3x plus 10. Okay, so now solve for x, that's 2x. Move this guy over, that's negative 6, so x is equal to negative 3. But before you box, make sure it checks. So check it right here in the radical form, because it's easier than the exponential form. Let's see what we got. Is cube root of negative 3 plus 4 the same as cube root of 3 times negative 3 plus 10? I don't know. This is a cube root of 1, which is 1. This guy is negative 9 plus 10 cube root, which is the same as cube root of 1. Is that right? And that's 1, so it checks. Therefore, this guy is our final answer. I hope that helps for you to solve some of the problems in this section, which are equations with radicals in them. Thank you.